Okay, so as I told you, this is problem 31, 31, 30 of the Origo book, second edition, yes? So let us read the problem first. A straight line through the origin intersects the curve y equals to 1 minus 0.25x squared at 2 points. Show that the tangents at the points of intersection are perpendicular to each other. Okay. So might be, I don't know which one is better, if I do it on GeoGebra first and then solve it, or the other way around. Might be, let us test this idea. I want you to understand what is the meaning of this problem using GeoGebra demonstration. So let me go to GeoGebra. The function that you have, what is the function? Y is equal to 1 minus 0.25x squared. Of course, it shouldn't be hard for you to be able to guess that this is the equation, this is the graph of your function. If you have, why this is 25 now? Oh, sorry, I have to fix this setting. This is, let me make it 3 decimals. Okay, so anyway. So these are the technical things that you have to be very careful in the national exam. Okay, so this is the graph. And then if I ask you, can you give me an equation of a line that passes through the origin? What do you write for its equation? Yes?
Y equals to
Kx. But we don't know what k is, but we know the m is 0. But you know what happens in GeoGebra if I write k. Of course, if I write k and then a space x, when I press enter, GeoGebra does not know what to draw. It will create a slider for you. Okay, so let us do that. As we predicted, GeoGebra produced a slider. By default, GeoGebra takes the slider from -5 to 5, but you can change this range. But this is good enough for the purpose of this problem. And for the time being, GeoGebra has assigned value 1 to k, so this is why the GeoGebra drew this line. And then how many intersection points you have? You have 2. So let me find those intersection points. Do you remember what I'm supposed to do? I go to the points, and then I click on intersect, and then I click here and here. I have these 2 intersection points. Now the claim is, if I draw the tangent lines, one at A, one at B, they will intersect one another in an angle which is 90 degrees. Okay, so let us check that. I go and ask GeoGebra to do that for me. Here, this is now the tangent. I click on my curve and I click on the point. GeoGebra will generate a line for me. If you don't mind, let me change the color so that it becomes more beautiful. Yes. So this is the first tangent line, and I will do the same thing for this point B. I will click on it and I will click here. GeoGebra generates another one, so let me right click on this one and then change the color. So let me this time, I don't know, make it which color you prefer. You don't have any preference, let me make it blue. So these are 2 lines. Okay, and then if you this is of course very clear, it should be 90, but if you don't believe in that, you can also do better. So you go to intersect again. I find the intersection between this blue and this red one. This is this one. And then if I want to measure the angle, I go to the angle and I have this angle. Okay. And then I click here, and I make my angle. Yes. It's 90 degrees. Okay, but this is not the hard part of the problem. The hard part of the problem is that no matter which line you choose, the points A and B will change. Yes? But this 90-degree angle remains the same. And we can demonstrate it very beautifully here. Let me change the value of k. You see, by changing the value of k, what is happening? Points A and B are changing, but that angle does not change. Is that understandable? So this is the purpose of this question. The purpose of this question is that regardless of which line passing through the origin you are choosing, the tangent lines are different all the time. But the angle between the tangents remains 90. And I think then you can have popcorn and watch the video, you know. So sometimes it is fun also to watch these kinds of videos. Yes, don't you enjoy? Yeah, very beautiful. Yes. So we want to prove this actually. We want to prove that this is the case. So that was the purpose of the question. But hopefully it is now more understandable for you. But of course, you don't have access to, if this is the given in the national exam, definitely this will be given in that part, but you are not access to GeoGebra. But hopefully you understand what is going on. So let us try to understand the problem now. So what should I do? I would say that, okay, I mean, for you, I mean, at this level, shouldn't be hard for you to sketch this graph in a proper way, not just the previous problem that I did for you, okay? Why this is the case? Because this function is famous, yes? So you have this function, but then you multiply it by 0.25, it doesn't change, it becomes a little bit steeper. But when you multiply it by a minus sign, it will actually find the reflection with respect to the x-axis, and when you add 1 to it, it will move it 1 unit up. Okay? So I'm not asking you to draw a very good picture, but at least you don't draw a very awful one, yes? So if I draw this one, hopefully you understand, this is more or less, it is easy for me to understand that the graph looks like this. Okay, this is still a scratch paper. And then I have a line that passes through the origin, and then you told, yeah, you understood it correctly, that a line through the origin has this y equals to kx. And then do you remember from GeoGebra, let me call this point A, let me call this point B. Okay, and what I want to show, this, of course, this picture is very far away from reality again, so we want to show that this angle is 90 if I draw these tangent lines. So that's the purpose of the problem. Yes? In order to show that the angle is 90, what do I need? I need the k value here. Let me call it k1, or let me call it k for point A. I need the k value here. Let me call it kb. I want to prove that ka times kb is -1. This is my target. So what I did, this is a scratch way work thinking, you know. So now my target is clear. I have to find the k value of this blue line, I have to find the k value of this blue line, and then I multiply them and confirm that the multiplication is -1 independent of what value of k is chosen. Okay, but this one, at least one part of it is a standard. If I want to find k of A and k of B, I have to find the k value of the tangent line. But for the k value of the tangent line, what do you need? You need derivative. This is the simplest possible derivative ever. But you need the x value of the point of tangency, here A and B. Okay, what is your proposal for finding the coordinates of A and B? This is a very standard problem. If you want to find the coordinate of two shapes, you set up a system, yes, and solve the system, yes. This is the equation of the curve, and this is the equation of my line. You have to pretend that k is given, and then solve this and find the intersection points. Solve means what? Means equate the y values. So kx should be equal to 1 minus 0.25 x squared. But this is a quadratic equation, yes? So I move it to the left. It becomes 0.25 x squared plus kx, and -1 equals to 0. But working with decimals is hard. If you don't mind, let me multiply everything by 4. If I multiply 0.25 by 4, I simply get x squared. Then this becomes 4kx minus 4. Okay? Okay, just to test your understanding. If I solve this equation and I get two answers, can you interpret what is the meaning of those answers? Yes? No, 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 no. They are not k still. Be careful. These are x's. One of them is the x coordinate of point A. The other one is the x coordinate of the other point. Because what I am doing so far, I am finding the intersection points. You see? This is one equation, this is another equation. When you set up a system, geometrically means when you solve it, you find the intersection points. So if I solve this one, it gives me 2x because that's a quadratic, hopefully. And this means one of them is the x coordinate of this point, because you see this line and this curve are intersecting at A and B. So if I set up the system and solve it, it will give me the x coordinates of the point A and B. Yes? Which part of it is not understandable? Are you with me or not? Okay. Okay. So let us solve it. So this I will solve it, but this is extremely simple. So how should I solve it? Let me use PQ formula. So what is PQ formula? X equals to minus P over 2. This is playing the role of P. This is playing the role of Q. So PQ formula is, what is the PQ formula? Is minus P over 2 plus or minus a square root of P over 2 to power 2 minus Q. Yes? So I will write it. It becomes minus P over 2, which is minus 2K, plus or minus. This number to power 2 is 4K squared. And minus Q becomes plus 4. Do you agree? Okay, that's it. But one of them with positive sign, we don't know which one is which because K is not a given number to me, so I don't need to waste my time, yes? One of them with plus sign is the x coordinate of one of these points. Which one we don't know, it depends which one is bigger, which one is smaller. And the other one with negative sign is the x coordinate of the other point. Yes? Is that clear? Okay, so these are the x coordinates of the point of tangency. So if I want to write something in front of them, x coordinates of the tangency points. Yes? Now, what I want to find the k values. But we have the formula, so I have to take the derivative of my function. This is my function. It is extremely simple to differentiate it, yes? So what is the derivative? The derivative of 1 is 0, yes? Sorry, the derivative of 1 is 0, and then 2 goes down, so it becomes minus a half x to power 1. So simple as that. So it becomes minus 0.5 x. Do you agree? This is the y prime. Okay, so one of them, if you don't mind, let me write x plus because it is too hard to write all the things. So let me write x plus with the plus sign. Let me write x minus for the minus sign. But what do I mean by x plus? I mean this part. And what do I mean by x minus? I mean this part. Yes? For simplicity of writing, I'm a little bit lazy to write it down. So now if I ask you what are the k values, you would say that one k value, one of them, I don't know which one is that. So k plus, I don't know if the plus one is A or the plus one is B. So I would say k plus is y prime x plus. Yes? And k minus is y prime k minus. Yes? But that is very simple. So it means that this is equal to minus 0.5 x plus. This means that this is minus 0.5 x minus. Are you with me or not? So what I am doing, one of them I call it x plus, the other one I call it x minus. Still I don't know, is this the x plus 1 or is this the x plus 1? But it doesn't matter, yes? So this is why instead of writing ka, kb, I wrote k plus and k minus. I know one of them is ka, the other one is kb. Okay? So if I ask you what is k plus, you will tell me that I take the derivative, which I did, and then I replace x with x plus, I get this. And if what is k minus, the same with x minus. And now what I am supposed to prove, I am supposed to prove k plus multiplied k minus is minus 1. So let us do it. K plus is 0.5 x plus, sorry, minus 0.5 x plus, multiplied by minus 0.5 x minus. Yes? But minus 0.5 times minus 0.5 is 0.25. X plus, x minus. Yes? And then I have to calculate. Then I cannot be lazy anymore. So finally, instead of x plus, I put this expression. Yes, and instead of x minus, I put this expression. Are you with me or not? Yes? Yeah, see, I try to avoid writing this mess, but at the end I have to. Yes. No, 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 0. Yeah, you are right. Thank you very much. Yes. Okay, but now can you see this pattern? This is a conjugate pattern. Yes, a number repeating itself here, another number repeats itself here and there, but once added, once subtracted. So if I ask you what is this, then this part becomes the first one squared minus the second one squared. Yes? Okay, so let us continue. So I have a 0.25 there multiplied by minus 2k squared. What is the answer to this one? Is simply 4k squared. But do you see that this power of 2 will cancel this square root sign, and this minus sign will go in. So it becomes minus 4k squared minus 4. And now the interesting thing you see, even though I didn't know k, this shows that I don't need to know k, because whatever k is, it is cancelled. And what is left for you is 0.25 multiplied by minus 4. But what is 0.5, 0.25 times minus 4? It's just minus 1. And that was the goal to prove, yes? So I wanted to show that regardless of what you choose for k, the k value of the tangent lines at the intersection points is always multiplied to minus 1. So you see, again, the algebra is not so complicated, but I consider this a hard problem at this level because you should be able to analyze the problem. Okay? So now I finish this one and we go to the next problem.